All right, welcome back. Today we are doing a tutorial on xflr5. Today we're going to be making airfoils and wings of various aspect ratios and comparing the coefficient of lift. So for this project, we are using NACA 2415. Basically, the way that the naming convention works is this 2 represents the maximum camber distance, the 4 represents where the maximum thickness is at, and 15 represents what that actual thickness is. And all these, this is in percentile, this is in 10 to percentile, so the 4 means 40% and the 15 means 15% thickness. So what we do is we put these numbers in here. I need to edit these. So I could just type in numbers. So once you've downloaded XFLR as correctly done, the first thing you would do is you'd go to module and click direct foil design. This would bring you to where you design your foil. Then you go to foil and you go to NACA, which is what we're using. And then we are using 2415. Leave the number of panels as is. And just click OK. And I guess we could just do this one as shown. And here is our new airfoil. So next up, we would be doing a direct analysis to get these 3 graphs. You simply get to this page by clicking on module and going over to direct analysis. Basically, first thing you must do is you must define an analysis. And you would click on type 2 to be able to change the data. So right now this is an AR of 10. And then click on type 1 because it's velocity. And basically, you would have to calculate your Reynolds number, which I calculated to be this. And it even gives you the values over here that you could use. With 50 meter per second wind, that's the Reynolds number I get. It doesn't automatically calculate it for you, despite having all the numbers necessary. You need to calculate it yourself, but that's relatively fine. You click OK. And I believe this is mine. I need to do a batch. Actually, I don't need to do that. I could just do this. And some points are unconverged. So after deleting the previous trial with the wrong Reynolds number, all you need to do, and these are your graphs. Obviously, if they aren't like as the needed parameters, what you do is you go to define graph settings and you change all the parameters here. So you can have like alpha, y, switch around the parameters needed for your specific graphs. Once you're satisfied, you'd want to export them. You go current graph and then export, and then just name it the appropriate graph. I already exported all of these, although I'm just gonna redo it again because why not? You just go to each graph you need and then press export. That'd be CO, and this one would be CD. And then now to move on to the next part of the project. For the next part of the project, we're going to need to look at 3D effects because stuff like induced angle of attack and downwash velocity are 3D aspects. So the first thing we need to do, we need to come over here. This was our direct analysis. Then we need to come over here and do wing and plane design. In order to start anything, we need to define a new plane. As we can see, when we click generate, there's some semblance of a plane here. We need to tune this to make it what we want. Immediately, we're going to unclick fin in the elevator, so that way it's just a wing. We're basically going to make this an airfoil. We need to go to define it. Ideally, we have this offset be 0. Just make it 0. And we want the chord length for both of them to be 1 meter. So we just do that real quick. And then the wingspan right now says 2 meters. And we need that to be 10 to have the aspect ratio of 10. So we make this 5. We make this 5. And there we go. The wing span is 10. So then we need to set the foil, which we have the NACA foil from the previous setup. Just to make sure it looks good. Yeah, it's very faint, but you can see the center line, and that is tapered. That is actually exactly what we need. Yep, everything looks good. NACA 2415 AR10. And we save it. And then just 2415 AR10. We can save the wing. Now we have our wing. We need to define analysis again. We're going to do a fixed angle. The project dictates here that we need to do a 5 attack. Therefore, we need to do a fixed angle attack. Coming back to here. Set up our analysis. I'm just going to change the name. AOA. And then we click analyze. Nothing happens. Time to troubleshoot. So the final part of this video requires us to plot the local lift, induced angle of attack, induced drag coefficient along the span of the wing. In order to do that, what we'd have to do first is we'd have to, so in this section I have the 3 different wings based on my required aspect ratios. And what you have to do is you have to do a type 1. So you go to analysis, like let's just say, I'll just make a new plane just for the sake of, I'll just name this like AR like 20. Like if we want to go this that far, define. I have to do this because I already, in my quest to troubleshoot everything, I managed to do it, but I didn't record it, so I have to do this over again. Just make the wing as previously shown. Put the NACA foil on both sections. Save it. This is our new wing. Has a wing area of 20. The span is 1. So with this wing, what we'd have to do is then define an analysis, fix speed, and then we would do a sequence of our previously stored values from -5 to 15. Make sure to store it because this is important. This thing pops up. And as you can see, now we have values on our graph. And what we do is we'd simply go to the required angle of attack. And there we go. This is our induced drag. You double click. You can get the induced angle of attack. You can get the local lift coefficient. Get the induced drag. And I believe those are the three things that are needed. Yes, those are. So that's how you would do that final part of the process.